Morena, welcome back to Breakfast. NASA has discovered methane gas is being generated on Mars, further supporting the idea that the planet once or still supports life. For more, we're joined by Auckland University physicist Dr. Nicholas Rattenbury. Morena, Nick, thanks for being with us.
Morena.
How significant is this?
This is very significant. This is a huge step forward along the path to answering the question, is there life on Mars?
Right, so we know that methane is being generated. Does Mars have cows?
Not sure. Haven't detected cows yet. I'm sure we would have if they do exist.
What can you actually tell? What does it mean when methane is being generated?
Well, what's happened is that the Curiosity rover on the surface of Mars has discovered organic chemicals in soil samples from Mars. Now, this is exciting because life is based on organic chemicals.
What is an organic
Things
chemical?
like carbohydrates, sugars, amino acids.
Right.
So life is based on these organic chemicals, and it also produces these organic molecules. So if there was life on Mars, then we would expect to see those organic molecules on its surface.
Right, okay. And if methane is being produced, that can come from a couple of different things, can't it? It can come from geological phenomena, or it could come from something like bacteria.
Exactly, yes. So we haven't got the definitive conclusion that there is life on Mars, but if life existed on Mars, it does exist on Mars, it should be producing organic molecules, and we've discovered organic molecules on Mars.
Wow. So where do we go from here?
Where do we go from here? Well, we need to send different experiments to Mars now to definitively test to see whether the methane, the organic molecules, is being produced by life processes.
It's not as simple as just taking some soil samples and trying to analyse it while you're there.
You could send a person, an expert geologist or microbiologist over there. That'll be quite an expensive thing because presumably they'd like to come back afterwards.
They might.
I know some people who wouldn't care one way or the other, but there again, there's these concerns.
But the Curiosity rover itself isn't equipped to do that.
As far as I understand it, it was sent there to look for evidence, the evidence that it has discovered, yes. It's a remarkably sensitive and delicate machine, yet NASA, JPL, these amazing institutions are able to send these very delicate and expensive, beautiful machines on top of a massive rocket, land it safely on top of Mars, and have them operate for years on end. It's amazing. From
all the information that Curiosity has gathered so far, where does this latest announcement rank?
Pretty high up there. This is it. This is probably the biggest announcement, I think, for the life on Mars missions that NASA have been sending to Mars.
And the interesting thing is that they have detected methane in the past, haven't they? But this is a varying level of methane.
This is an exciting part of it, is that Curiosity on Mars's surface has, as you say, detected methane, one of these organic molecules. It's the simplest organic molecule, and they've noticed the amount changing over time with the Mars seasons. What this means is whatever is producing the methane on Mars is going on at the moment. It's an active process.
Ah, right. So it could be something underground, or it could be life.
It could be bacteria underground, for instance, or it could be a geological process underground which is producing the methane, yes.
That's very exciting. Thank you so much, Nick.
You're welcome.
Great to chat, as always. Nicholas Rattenbury from Auckland University. Remember, if you want to send us your feedback, you can go to our Facebook page. It's Breakfast on One on Facebook, or flick us an email, breakfast@tvnz.co.nz.
Here's what's coming up in the next hour of the show. Afternoon.